In surveying, meridians and bearings play a crucial role in determining and expressing directions between the points. So, in order to grasp the concept of meridians, bearings, and surveying, it is very essential to comprehend a fundamental concept about how these meridians are being derived and how they work. We know the fact that the Earth rotates around an axis that connects the North and the South poles. These poles are widely recognized as true North or the geographical North, as well as the true South or the geographical South. In the field of geography, we utilize a system of imaginary lines to define and understand the different regions on Earth's surface. So these lines include latitude, which extends horizontally from west to east, and longitudes, also called as meridians, which extend vertically from the North Pole to the South Pole. Meridians, also called as a line of longitude, are imaginary lines that run from the true north to the true south poles along the Earth's surface as shown in the figure. This is the exact geographical definition that has been provided. As shown in the figure, based on the definition, there are several longitudinal lines that are possible. As the Earth is spherical, to be more exact, an oblate spheroid, the total angle is 360 degrees, and hence the longitudinal lines are placed at a gap of 1 degree, thus giving a total of 360 longitudinal lines along the Earth, as shown. Hence, these longitudinal lines are measured from 0 degrees to 360 degrees. So this is the basic concept of meridians. Let's dive into the different types of meridians and how they are being used for surveying. Number 1 is prime meridian. Prime meridian is an imaginary line that runs from the North Pole to the South Pole, dividing the Earth into the Eastern Hemisphere as well as the Western Hemisphere. The prime meridian is established at a longitude of 0 degrees and act as a starting point for measuring longitudes around the globe. Hence, there is only one prime meridian possible, and the most widely recognized prime meridian is the one that passes through the Royal Observatory in Greenwich, London. This prime meridian, commonly referred to as the Greenwich meridian, was internationally adopted in 1884 at the International Meridian Conference. Prime meridian provides a standard reference for the cartographers, navigators, and scientists to accurately determine the geographic coordinates of any place on the Earth. Number 2 is true meridian. True meridian is the line of longitude that runs through the Earth's true north and true south. The true meridian at any point aligns with the Earth's axis, that is, true north as well as the south pole. Each point on the Earth's surface can have its own unique true meridian. As you move eastwards or westwards from the prime meridian, the longitude values of the true meridian will vary. For example, a location with a longitude of 45 degrees will have a true meridian that passes through that point and has a longitude of 45 degrees. True meridian is established by astronomical observations and it is fixed for a particular point of location. The direction measured with respect to true meridian would not change as the true meridian is a fixed direction. For most surveys, the true meridian is used especially for demarcating property lines. Number 3 is magnetic meridian. The magnetic meridian is an imaginary line that represents the direction of Earth's magnetic field at a specific location. To be more precise, it is a reference line that passes through the magnetic north as well as the magnetic south. Hence, it is a line that runs perpendicular to the surface of the Earth and passes through the point where a compass needle points to the magnetic north. The magnetic meridian indicates the direction in which the magnetic compass needle aligns itself in response to the Earth's magnetic field. The magnetic field of the Earth is not uniform and it varies in strength as well as direction across different locations. So the magnetic meridian at a particular point may not be same at another location. The magnetic meridian is important in navigation and compass use because it provides a reference for determining directions relative to magnetic north. By aligning a compass needle with magnetic meridian, one can establish the north-south axis and navigate using the magnetic bearings. It is important to note that the magnetic meridian is not same as the true meridian, which represent the line of longitude passing through a specific location. The magnetic meridian and true meridian can differ due to the variation in a magnetic declination, which is the angular difference between the magnetic north as well as the true north. We have already made a video on what is declination in surveying, and the link will be given in the above card mentioned. As shown in the figure, with location, the magnetic meridian as well as the true meridian varies. So this way, infinite combinations of magnetic meridians, that is passing through magnetic north and magnetic south, as well as infinite combinations of true meridian passing through the true north and true south are also generated. The magnetic meridians, as explained, are represented as dotted lines in this figure, and the true meridians are represented as non-dotted lines. So if you consider a point A where the magnetic meridian and the true meridian deviates by an angle of alpha, which is the declination angle alpha at particular point A. If you choose a point B, the declination angle will be beta. So this is how the declination angle is calculated. So it varies based on the point that is being selected. As shown in the figure, with location, the magnetic meridian as well as the true meridian varies. So this way, infinite combinations of magnetic meridians, that is passing through magnetic north and magnetic south, as well as infinite combinations of true meridian passing through the true north and true south are also generated. The magnetic meridians, as explained, are represented as dotted lines in this figure, and the true meridians are represented as non-dotted lines. So if you consider a point A where the magnetic meridian and the true meridian deviates by an angle of alpha, which is the declination angle alpha at particular point A. If you choose a point B, the declination angle will be beta. So this is how the declination angle is calculated. So it varies based on the point that is being selected. In addition to the true and magnetic meridian, we have a third meridian type, which is an arbitrary meridian. An arbitrary meridian refers to a selected line of longitude that is chosen for the convenience or specific purpose, rather than being based on any established reference point or any natural features. It is a meridian that is not aligned with any significant geographic or magnetic marker. Unlike the prime meridian, which is internationally recognized and established as the reference point for measuring longitudes, an arbitrary meridian can be any line of longitude that is designated for a particular project or for a local use. Hence, it is often chosen based on convenience, ease of measurement, or the local requirements. Arbitrary meridians are sometimes used in small-scale mapping or surveying projects that do not require global or standardized references. They can be established to facilitate regional or local measurements where precise alignment with the prime meridian may not be necessary. Number 5 is grid meridian. Grid meridians are lines that are a part of coordinate grid system used on maps or chart. In a grid-based coordinate system, a grid meridian is a chosen line of reference that runs parallel to the meridians of longitude on a map or a grid. It is a constructed line that facilitates the measurement and plotting of coordinates on a grid system. They are often represented as vertical lines on a map intersecting with the horizontal lines that are the parallels to form a grid. Grid meridians are based on a specific projection or coordinate system used for map. Unlike meridians, which cover towards the poles, grid meridians are typically straight and parallel, allowing for easy measurement and navigation. This is the part 1 video of meridians and bearings. As you understood the concept of meridians, we'll be coming with the part 2 section of bearings. I hope you have a clear understanding of the basic concepts of meridians and bearings. I have provided a detailed explanation for each meridian and how bearings are derived to help you grasp their significance. For more such innovative and informative videos on civil engineering and construction, subscribe and share to our channel Civil Engineering Fanatics.